So let's calculate these numbers. Of course, this one, the sum of the x's, we did it for the mean, so we know what that is. But let's quick go over it again. So this one is the sum of the x's is to take each number and add them up. And so on. I'll write them all down, and we get 229. Alright, so this other symbol, these are different. Okay, so the key here is this one, you square the numbers first. So we get x squared, which from writing it down, they look almost alike. So you just square each one of them separately, and you add them all up this way. And of course, when we do that, we get 4,497. Now the other thing is the n. The n is the same. If we count them all up, there's 13 of them. Now, once you have these three numbers, it's just a matter of plugging them into the formula. So if it's a population, we would have 13 times 4497 minus 229 squared over 13 squared. Alright, if it's a sample, you get s squared, because we changed the symbol, 13 times 4497 minus 229 squared over 13 times 12. Now let's do these on the calculator. So remember, you want to do the numerator for the denominator, so we put in 13 times 4497 minus 229 squared divided by 13 squared, and we get, as you can see, 35.6, and because of the rounding rule, we'll round it off to one decimal place, 35.6. Now, if this is a sample, again, the numerator is exactly the same. But this time, we have 13 times 12. You can do it ahead of time, or if you do it on the calculator, you can use 13 times 12, and you get 38.6. Round off to one decimal place because of the rounding rule. That's the variance. So the last thing would be to find the standard deviation, the square root of the variance. So that's really not that hard. The standard deviation here would be 35.6. Take the square root of it. Standard deviation here would be 38.6. Take the square root. Just plug these into your calculator. 35.6. We get 5.9, so I guess we round off to 6.0. Alright, so this one for the sample, 38.6 square root, and you get 6.2. Slightly different, but not a whole lot.